This is the review for algebra for the chapter 4 test. This is what we did in class. In question number 1, and these questions look exactly like your test questions do. Write an explicit formula, then determine the 20th term in the sequence. So when I'm taking a look at these numbers, I'm looking at 16, 24, 32, and 40. You have to figure out, first of all, whether it's an arithmetic sequence that you're adding or subtracting by the same number each time, or whether it's a geometric sequence that you are multiplying by each time. If you're trying to figure out that if it is an arithmetic sequence, try subtracting the numbers going backwards. 40 minus 32 is 8. 32 minus 24 is 8. 24 minus 16 is 8. If you're trying to figure out if it's a geometric sequence, you want to divide the numbers going backwards. 40 divided by 32, and then 32 divided by 24, 24 divided by 16. Well, you're not doing that. You're really adding by 8 each time, because when you subtract, you're subtracting by 8 each time. So what we're really doing here is adding by 8, adding by 8, adding by 8. We want to write the explicit formula. So when we write the explicit formula, it is a sub n, the term that you want, equals the first term. All right, this would be your first term, a sub 1, which is 16, plus your common difference. The common difference is what you're adding by each time. So plus 8 times n minus 1. That is your explicit formula. Then it also asks you to find the 20th term. So using that formula, we want to find the 20th term in the sequence. That means that n equals 20. So that's your 20th term. So instead of a sub n, I have a sub 20 equals 16 plus 8 times 20 minus 1. You're going to take this part and type it right directly into the calculator, exactly how it looks with the parentheses. And you get that the 20th term in the sequence is 168. Again, you have to do both the explicit formula and the 20th term. Remember, with your explicit formula, it is a sub n equals, and you have an n here. That explicit formula will tell you any numbered term that you want. You can figure out the 100th term, the 1000th term, the 500th term. So you want a sub n equals, and you want an n right here, because you could put in any term number there. When we take a look at 1b, write an explicit formula. So again, we want that generic formula, and then determine the 10th term. So that means n is going to equal 10 in the sequence. When I take a look at this one, I see 3, 12, 48, 192. I can tell right away that we're not adding by the same thing each time. We're not subtracting by the same thing each time. We're definitely multiplying. So again, I'm going to work backwards, and I'm going to do 192 divided by 48. I'm going to do 48 divided by 12. I'm going to do 12 divided by 3. Remember, they're going to be the same every time. Well, 12 divided by 3 is 4. So what I'm really doing is times 4, times 4, times 4. And you could always check those if you wanted to. You could have done the same thing on the previous one and checked all of those if you really wanted to by adding 8 each time. Here we're multiplying by 4, so it's a geometric sequence. For the explicit formula, g sub n, the term that you want, equals the first term. Your first term is 3 times your common ratio. Your common ratio is what we're multiplying by each time. So times 4 to the n minus 1 power. That's your explicit formula. You are going to have to write that on your test. Now they want you to find the 10th term. So g sub 10 equals 3 times 4 to the 10 minus 1 power. Remember, that is an exponent. If you wanted to do 3 times 4 to the 9th power, that's fine. Just be careful. You can't do the 3 times 4 first, because you have to do your exponents first. So type this into the calculator exactly how it is. Remember, you would have to use the caret button. 3 times 4 caret button, 10 minus 1. All right, be very, very careful there. So we get g sub 10 equals 786,432. For the next one, 1C, write an explicit formula and then find the 35th term. So again, n equals 35 here for our 35th term. When I'm taking a look at it, I can see that it's going by twos each time, but we're not going by +2. We're adding -2 or subtracting by 2 each time. If you couldn't figure that out, we could go backwards and subtract the numbers. -40 minus -38 is -2. -38 minus -2 is -36. And keep on going like that. So this means that our common difference is -2. Our a sub 1, our first term, is -34. The term that you want for the explicit formula is a sub n equals the first term, -34, plus your common difference. Now we're not going to do plus, we're going to do -2 because it's a -2 times n minus 1. Type that right into the calculator. But before we type, before I'm getting ahead of myself, before we type it into the calculator, we want to find the 35th term. So a sub 35 equals -34 minus 2 times 35 minus 1. We need that 35 in there first before we type it into the calculator. Now you have that. Type it into the calculator. We get that the 35th term is really -102. In the next one, consider the sequence shown below. So I'm going to call these trucks. We have 2 trucks, then 5 trucks, then 8 trucks. Well, how do you get from 2 to 5 to 8? I can clearly see that we are adding by 3 each time. So we know that it's going to be an arithmetic sequence and we're adding by 3. It says, in a complete sentence, describe the pattern. It is a very, very common mistake to just say that we add by 3 each time, add by 3 trucks each time. However, if you think about describing the pattern, if you're adding by 3 trucks each time, how many trucks are we starting with? You don't know. You could be starting with 1,000,000 trucks, all right? So we have to say, start with 2 trucks. Then add by 3 trucks each time. You have to say this, start with 2 trucks. So start with how many and then add by how many each time. Be very careful there. Write a numeric sequence to represent the first 6 figures. They give you the first 3, 2, 5, and 8. They want you to write the first 6. So if we add 3 again, our next number is going to be 11. Add 3 again, our next number is going to be 14. Add 3 again, our next number is going to be 17. Be careful. Another common mistake is not doing enough of them, like forgetting these 17 or doing too many. They only want you to do the first 6. So you need 2, 5, 8, 11, 14, and 17. Using that same pattern with the trucks, it says, write an explicit formula for this sequence. The explicit formula, a sub n, the term that we want, equals the first term, a sub 1, all right, which is 2, plus your common difference, which was 3, times n minus 1. That's your explicit formula. Determine how many would be in the 8th picture. So n equals 1, or sorry, n equals 8. So a sub 8, that's hard to say, equals 2 plus 3 times 8 minus 1. Type this right into the calculator, and you get that the 8th term in the sequence is 23. Determine the 20th term in the sequence, defined by a sub n equals -4 plus 2 times n minus 1. That means this 20 is n. So n equals 20. A sub 20 equals -4 plus 2 times 20 minus 1. Just type this right into the calculator, and you should get that the 20th term in the sequence is 34. Number 4 and number 5 are going to require a little bit of graphing. Complete the table for the given sequence, then graph it on the coordinate plane. Whatever formula they give you, this is really, you're going to type it into your y equals, and then hit second and table for the points. So in your y equals, you're going to type in 5 times 3 caret button n minus 1. And then you're going to hit second and table. When you hit second and table, these are your x values, these are your y values. You get 5, 15, 45, 135, 405, 1,215, 3,645, and I'm just reading these right from the table. 10,935, 32,805, 98,415. So now I'm ready to graph it. Remember that your x values go down below. So our x values, you always start with 0 right here in the corner. We're going to count by ones because that's what our term numbers go by. We have to label our axes. What are these? These are the term numbers. When I go up along the side, my lowest number is 5. My biggest number is 98,000. I know I have to start with 0 in that corner. So if my biggest number is 98,000, I want to count by 10,000. So each block is 10,000. So I'm counting by 10,000s going up. And I need to label it along the side. This is the term value. Make sure you label them. When I go to graph it, your term number, your x value is how many go over. Your y value or term number is how many go over. Term value is how many go up, because that's your y value. So over to 1, up to 5. It's going to be right on the bottom. Can't even tell. Remember, each block is 10,000. 15, 2, and 15, 3, and 45. Can't tell the difference still because the box is so small. 5 and 405, you still can't tell. Now it's going to be up a little tiny bit, and then up to 3,000. So it's going to be about a third of the way up in 7, and then 10,900 just above the 10,000 there. Then we have 32,000, and then all the way up to 98,000. Don't connect the dots. All right, it's just like that. It is a discrete graph. For the second one, this time we have an arithmetic sequence. Again, type this right into your y equals, and then second and table for your points. So when you type it in, you get that 1 is 95, and then we have 90, 85, 80, 75, 70, 65, 60, 55, and 50. And I got those right from the table. Notice that your common difference is 5 right here. All right, that's why we were subtracting by 5 each time, because it's 95 minus that amount. So because your difference was -5. So when we go to graph it, these are your x values, these are your y values. So across the bottom, we have the term numbers, always 0 and 0 right here in the corner. So we could just count by ones going across the bottom. And we need to label it. These are your term numbers across the bottom. Going up along the side, my lowest number is 50. My biggest number is 95. I think counting by tens would make the most amount of sense. Could you count by 20? Sure. Could you count by 25? Sure, but you're going to have a really tiny graph then. So I'm just going to count by tens to sort of maximize my space. But again, we wouldn't want to count by 10,000s. You wouldn't be able to see it. So, and these are your term values along the side, because these are your y's. When we go to graph it, 1 and 95, this is how many you go over, this is how many you go up. 1 and 95, 2 and 90. Then we have 3 and 85, 80, 75, 70, 65, 60, 55, 50. Notice that it forms a straight line. Remember, geometric sequences, we're going to see a question like this later. Geometric sequences are curved like that. Arithmetic sequences are straight lines like that. We don't connect the dots. In question number 6, tell whether each graph represents an arithmetic or geometric and sequence and explain your reasoning. So we can see that this is a curved graph. That single curve is a geometric sequence. And we know it because it forms an exponential curve. This one forms a straight line. All right, so it's linear. Therefore, it is an arithmetic sequence because it forms a line. Curved are geometric, lines are arithmetic. In question number 7, on the test, these will be multiple choice. It says, Mary likes to sketch charcoal drawings and currently has 12 hung on her walls in her art studio. She plans to draw and hang 3 paintings per month in order to decorate. This sequence is represented by 12. She starts off with 12. She hangs 3, now she has 15. She hangs 3, and now she has 18. She hangs 3, and now she has 21. So what we're really doing each time, we're starting with 12 and then adding 3 each time. Write the explicit formula. Remember, this will be multiple choice. So this is an arithmetic sequence. So a sub n equals the a sub 1, which is your first term, 12, plus the common difference of 3 times n minus 1. That's going to be the explicit formula. You can use that formula to find any term number. In number 8, again, this will be multiple choice. Given the following sequence, 500, 200, 80, 32, 12.8, write the explicit formula that represents the situation. I know right away that it's not arithmetic because to get from 500 to 200, I have to subtract by 300. To get from 200 to 80, I have to subtract by 120. Those numbers are not the same. Therefore, I know that it's geometric. Well, how can I figure out what the common ratio is? I can figure out the common ratio by dividing, going backwards, all right? We want to do 200 divided by 500. 200 divided by 500 is 0.4. I could also do 80 divided by 200, or I could do 32 divided by 80. If we do all of those, you see that all of them are 0.4. So divide going backwards to find your common ratio. So write the explicit formula. G sub n equals the first term, 500, times the common ratio, which we found to be 0.4, to the n minus 1 power. In question number 9, Pine City Elementary is holding a 10-day canned food drive. To start off the drive, the principal donated 25 cans. So you're starting with 25 cans. After day 1, they had 36 total cans. After day 2, they have 47 cans. After day 3, they have 58 cans. If the pattern continues, how many cans will they have after day 6? So we need to figure out 4, 5, and 6. Well, how do you get from 25 to 36 to 47 to 58? I can see that I am adding by 11 each time. 58 plus 11 is 69. 69 plus 11 is 80. 80 plus 11 is 91. How many will they have after day 6? It is 91 cans. I would write it out like that. I think it's very helpful. In question number 10, again, this will be multiple choice. Write the explicit formula for the arithmetic sequence in function form. All right, when it says in function form, you have to take your common difference here and distribute and distribute. We need to get rid of those parentheses for it to be in function form. So we also want to change the ace of n to be f of n because that's in function form. Equals, when we distribute, we would have 8 minus 3n. Negative 3 times negative 1 is positive 3. I need to combine my like terms here. So f of n equals, and I could say negative 3n plus 11. 8 plus 3 is positive 11. That's why I have plus 11 there. That's in function form. Remember that you need that f of n equals because it says in function form. So we wanted to do the distributive property at the beginning, combine our like terms, and we need it set equal to f of n. In question number 11, write the explicit formula for the geometric sequence g of n equals 4 times 6 to the n minus 1 power in function form again. All right, in function form means we need an f of n equals. In this one, now these ones are a little bit weird. What we want to do is we want to take this part right here and we want to separate it. All right, we want to separate it into two things so that we really have 4 times, we want to separate the exponent, 6 to the n times 6 to the negative first power. We're taking that and we are separating this into 2. All right, 6 to the n and 6 to the negative 1. Just like we did before, we want to combine our like terms. But when we combine our like terms, we're really multiplying these two terms together because they're just plain numbers. 4 times 6 to the negative first power. 4 times 6 to the negative 6 power is, if you put it as a decimal, it would be 0.6 repeating. If you put it as a fraction, you might get 4 over 6. I would just put it as a decimal, it's just easier. Times 6 to the n power. We can't combine those two. So now we just have f of n equals 0.6 repeating times 6 to the n power. But again, we want to split that exponent. 6 to the n minus 1 becomes 6 to the n and 6 to the minus 1. In question number 12, in a complete sentence, describe the pattern below. Just like we had with the trucks before. What are we starting with? Start with 4 stars. That's what I'm going to call them. And then how do we get to 8 and 16 and 32? Well, what we're doing each time is multiplying by 2 each time. Then multiply by 2 stars each time. Multiply by, not by 2 stars, but just by 2 each time. So start with 4, then multiply by 2. In question number 13, determine if the sequence is arithmetic, geometric, or neither. Again, to figure out if it's arithmetic, you want to see if you're adding or subtracting by the same number each time. I can clearly see that going from 5 to 20 to 80 to 320, you're not adding or subtracting by the same. So the easiest way is to divide going backwards. All right, divide going backwards each time. All right, so if I do 30 divided by negative 320 divided by negative 80, I know that that is negative 4. Negative 80 divided by 20 is negative 4. 20 divided by negative 5 is negative 4. So I can see that I am doing times negative 4, times negative 4, times negative 4. I'm multiplying by the same number each time. So that is geometric. And identify the next term in the sequence. So times negative 4 again, 320 times negative 4. The next number in the sequence would be negative 1,280. In question number 14, determine if the next term in the sequence. Again, you have to figure out, is it arithmetic or geometric first? Right? If it is arithmetic, we would be adding by the same amount each time. I can see that these numbers are pretty close, so we might be adding by the same number or subtracting by the same number each time. You could figure out geometric by dividing going backwards. I'm going to subtract going backwards. Negative 0.79 minus negative 0.31 is negative 0.48. Negative 0.31 minus 0.17 is negative 0.48. Negative zero, or sorry, not negative, but positive 0.17 minus 0.65 is negative 0.48. I'm subtracting by 0.48 each time. So if I do that one more time onto here, my next number would be negative 1.27. And in the last question, determine whether the sequences are arithmetic, geometric, or neither. In letter A, you could try subtracting going backwards. You won't get the same thing each time. You'd get a +6, +7, +8, +9. That does not automatically mean that it is geometric. It could be neither, all right? You have to try dividing each time, all right? Going backwards, 44 divided by 35, 35 divided by 27, 27 divided by 20, 20 divided by 14. They're not the same either. So what you're doing here is you're really adding by 6, adding by 7, adding by 8, adding by 9. This is your neither pattern. Remember, to be arithmetic, it has to be the same number each time. Negative 50, negative 45, negative 40, negative 35. I can clearly see that I'm adding by 5 each time. If I'm adding by 5 each time, it is arithmetic. 1.25, 0.25, 0.05, 0.01. Again, divide going backwards. All right, divide going backwards. When we divide going backwards, you get 0.2, 0.2, 0.2. What you're really doing here is multiplying by 0.2 each time. Since you're multiplying by the same thing each time, it is a geometric sequence. And that's what your test looks like.